Hey, did you hear about that new movie released about clocks? Yeah, it's about time. Haha. Okay, let's get to it. We are looking at world time zones. All right, so basically, depending on where you live on this earth, the time changes. That's why when one half of the country is, or one half of the world is awake, the other half is asleep. All right, so the position on the earth, it determines your time zone. Okay, now you can use your phone. But in the exam, not going to happen. So we'll give you two methods. We're either going to give you some coordinates and you have to find that way, or we'll give you a simplified map and you can kind of do it that way. Now, using your coordinates, the reason that I say we use longitude is because longitude is the one that determines the time. Okay, your latitude doesn't really change, affect time too much. It's mainly your longitude. So a couple of things when we're using coordinates, we need to remember this. Now, if I'm talking about a sphere, or let's say even when the world rotates, how many degrees is in a sphere? Okay, the reason this is important is I need you to logic this through. Okay, there's 360 degrees uh, in one full rotation in one full day. And we also know that a day is 24 hours. And so what we want to do is if I want to find out how many degrees it turns per hour, I just go 360 divided by 24. I'll write that down over here. And what that will tell you is your answer is 15. So what that means is 15 is our magic number for this kind of part. Just remember that every 15 degrees represents a 1 hour time difference. Or you can look at it the other way. Every 1 hour, 15 degrees has rotated of the earth. Okay, that's why 24 hours, 15 degrees. If you don't remember the 15, just remember that there's 360 degrees in a day, and one day is also 24 hours. That's how you can kind of backtrack and figure it out. Now, big hint here, where possible, draw a diagram. Doesn't have to be fancy, doesn't have to be great. Just draw a diagram because that will tell you a little bit about your time zones. Now, let's say, for example, Sweden is approximately located at 58 degrees north, 15 degrees east. Sydney is approximately located at 33 degrees south, 150 degrees east. Find the time in Sydney if it's at 6 a.m. in Sweden. So this is a stacked question. And if I just kind of gave it to you on your own, I'm sure there's nicer ways to figure it out in your head. But I want you to put it down on the paper just for the first couple of times until you're confident that you've picked up the pattern yourself. Now, what I'm going to do is let's talk about Sweden. We'll do Sweden in green. And I'm not even going to make it too fancy here, but I just want to see where they're located in regards to each other. So what I've got here is I've got my blue line. So that's your 0 degrees longitude. There's your 0 degrees latitude. Now, if I'm going these coordinates here, 58 degrees north, 15 degrees east, okay? And maybe I'll draw a little, okay? Never eat soggy Weet-Bix. Okay, so what I've got here is I've got 58 degrees north, so I'm slightly up. And then I've also got 15 degrees east, so I travel a little bit to the right. And what I'm going to do is I'm just going to label that as Sweden. Okay. And if I wanted to, I could draw the lines going through it. But right now, I just know that I'm 50 degrees up and I'm about 15 degrees east. Okay. Now, I'm going to do something similar for Sydney. So it says approximately at 33 degrees south and 150 degrees east. So let's pick a different color. How does one pick a good color? All right, let's go to Sydney. So Sydney is 33 degrees south, so that means it's below the equator, and 150 degrees east, so it's fairly far on the other side. Let's say that this here is Sydney. Okay, now what this tells me is I can find out, okay, I want to find the difference between here and here, in particular, this, how far across it is, okay? Now, the way that we do that is that's governed by the longitude. So in other words, it's going to be 150 degrees because that's the Sydney longitude. Maybe I should color code this. That's the Sydney longitude. And then what I'm going to do is to find the difference mathematically, that means minus. And so I'm going to minus whatever it was for Sweden. which is 15. So 150 take away 15, that gives you 135 degrees. Now, what this tells me, if it's 135 degrees, I'm hoping it's a nice number. Now, what I do is I remember that 15 degrees equals to 1 hour. Right, this is my standard kind of rate, but if I'm talking about 135 degrees, I recognize that that is a 9-hour difference. And the way I did that was mathematically. I hope you guys are catching on. It's just 135 divided by 15. That gives you 9. Okay, so now I know it's a 9 hours difference. And the thing that I'll note here is, just take a quick note. This is in front. And this is behind. So the way that time works is if you're on the right-hand side, you're in front. If you're on the left-hand side, you're behind. So now I can see with this, Sydney is 9 hours ahead. Sid equals 9 hours ahead of Sweden. And then from here, it's 6 a.m. in Sweden. And then so all I got to do is plus 9 hours to that. So 6, 7, 8, 9, 10, 11, 12 p.m., 1 p.m., 2 p.m., 3 p.m. Hopefully you can do that math in your head. So therefore we can say it's, that's the Sydney time. It'll be 3 p.m. in Sydney. That would be an example of how to find the time. Okay. Now your other one, simplified diagram, just a couple things about this. So hopefully that makes sense. Stop it and slow it down. I know I got a little bit rambly towards the end. My apologies. Now, a lot of the times they'll give you a simplified diagram, and these ones are quite nice. A couple things to note about this is when they talk about the UTC, we call that the Coordinated Universal Time. I know it should be CUT, but just Universal Time Coordinated. That's what they mean when they talk about the 0 degrees longitude, or they used to call it the Greenwich Mean Time, or the GMT. That's your center, and then everything towards the right is a plus, everything towards the left is a minus. And I will show you exactly what that looks like. Now, please bear with me. Hopefully you guys can see my screen. Now, you can see here that this dotted line here, there's your 0. That there is your 0 longitude. It's your Greenwich Mean Time. It's your UTC. That's the center. Okay, now the way that we use this is, let's take a look at a question. Let's say, for example, it's 4 p.m. in Moscow. Find the time in San Francisco. So Moscow is here. San Fran is all the way here. Now, the way that I need to do it is, first things first, let's find the time difference. Okay. Now, to take a look at this time difference, we can see that the time difference is, I kind of need to use that 0 as my middle point. So that means from -8 to 0, that's 8. Right? Because you can see that San Fran is here. And then to get to Moscow is another +4. So what that tells us is, it tells us that there's a 12-hour time difference. Okay. So our time difference here is 12 hours. That makes our life very, very easy. If it's 4 p.m. in Moscow, that means it's 12. That means San Fran is 12 hours behind. Okay. So 12 hours before 4 p.m. 12 is a very nice one. It will actually be 4 a.m. in San Fran. Okay. And all I did was 4 p.m. take away 12 hours, right? Because I'm going back. So I hope that helps. All the best, and I'll catch you in the next one. All right. Bye.